So, good evening, everyone. Welcome to the very last talk of the day. I hope you will enjoy it. I will take you behind the scenes of an RSE product, so an RSE software that we have been developing. And it's a very particular choice of words. I call it popular. So, of course, it's maybe not the best out there, but it is popular and might not be the most used software in its class, but popular because we generally get very, very positive feedback from our users. So, and I will come to the reason for that at the end of my talk. So to begin with, yeah, the problem we are tackling is of lab notebooks and how documentation is done in laboratories. Science has progressed a lot during last 100 years. So yeah, this is an image from a lab notebook in 1927, and 100 years later, we are somewhat in the same place if you're not using an electronic lab notebook. And a lot has happened between then. There have been supercomputers moving from rooms into your pockets. So yeah, things need to change. Also, our devices have changed. We record data digitally, also by hand, and we publish data digitally and also on paper. Yeah, sometimes we have links to the data, files to be downloaded. The worst of all is supplementary information where you have a lot of data in not even human readable format sometimes. So yeah, it's a problem, and it's essentially the core of our research data management problem. Of all this, of course, none of it is very fair. Yeah, I will be preaching to the choir if I go on to describe what is the problem over here and why we need electronic lab notebooks. Well, so what we are trying to do, or what we have done, is we have built Chemotion. It's yeah, almost been more than 10 years now since the project started. Chemotion initially started as an electronic lab notebook for chemists. Now it is diverging into more fields, and we are trying to expand. But really, it is what we are trying to do is we are building an electronic lab notebook for the future. So our goal is, of course, to make all the data that researchers have fair and have better research data management while keeping the software that does that in open source. So there are other vendors who promise to make data fair. Some of them have open source, partly open source. Some are completely open source, so we are veterans. And some are competitors in the sense they're closed or proprietary. And yeah, uh, the strong points that we have is we are like the entire project was thought of by researchers. It has been created by researchers and for researchers. And we have taken care over the past 10 years to keep up with the standards, to integrate where required, and yeah, basically ingrain the entire philosophy of this conference into the product as much as we can. Um, yeah, so just to give you a timeline of our um, uh, okay. Just to give you a timeline, so the idea was thought of in 2012, and it was implemented in Ruby on Rails, Postgres, with a web front end. This was a particular choice because we want the end user to be able to access the ELN wherever they are. So they don't really need to install anything on the system as long as they have a web interface, which is basically any modern PC. The initial funding was very generously coming from the university, from the state of Baden-Württemberg, and then eventually the DHE. And at the very beginning of the project, it was 2 PhD students and 3 full-time people. So when I say full-time, postdocs. Fast forward to today, what we are now, we are moving towards modularity. So we are, as I said, moving away from just being focused on chemistry to also biochemists and other fields as much as possible, while keeping true to the spirit of being, first and foremost for chemists. Uh, this also shows up in on our tech stack. So as I'll cover later, when it was written, it was monolithic architecture. It was a single code base doing a single thing. And now we have been trying to move it away and have a plethora of microservices that handle different kinds of use case scenarios. And the end goal is that uh, the end user will only be using the microservices or installing the microservices that they require. We have been greatly helped by NFTI for Chem. So this is the umbrella project that has been funding us for the past few years since 2020. And of course, all the ones on the left, NFTI for Chem also comes from DFG. Uh, with NFTI for Chem, we have had the opportunity to greatly expand our team and also have input from our collaborators. So just counting on the developers, we are approximately, at any given point of time, 10 to 15 developers in the team working on the project, which is great fun. And we also are able to hire external developers if required, which is sometimes a very good idea. So the usual setup for the ELN, it sits at the center of everything, and it can talk to your devices directly. So as soon as you do an experiment, if you're logged in, it goes to your folder on the file server. It then comes up directly into the ELN as an attachment, so there's no moving of files on the end user part. The end user just moves directly from the device to the browser access in the ELN, and the file is automatically there because they just finished the experiment. The ELN itself is backed up. We need to set that up when we are installing the ELN. And at the end of everything, when you have done your experiment, through which the ELN helps you in a lot of manners. This is not a clever chemist, so I'm not going to into those details. But yeah, you can basically do the entire experiment within the ELN in terms of thinking through and getting to your result, including the analysis. And at the end of it, we keep up with the spirit and move the data to a repository so that it is not just your results are available through a paper, but also your data is available at a repository where people can access it using POIs. So what we do shows up, because it's an overlap of research and software. Our architecture is very much inspired by how research is done in the lab. Here is an example. Of course, the core remains the same, but our services depend on what the researcher wants. So for example, we have a service called ChemConverter that is used to convert files. We have a service called ChemSpectra that can draw spectra for you and help you analyze and annotate that. And then we also work with collaborators, externally available services, and plug that in as much as possible because that's what the chemists want. Sometimes they don't want to use the tools that you provide. They are comfortable with the tools that they have, and that's how the synergy works. So going from the device to repository, the entire tool chain we try to keep the entire tool chain through the interface of our ELN. And for example, we have this service called ChemConverter that can convert your file and help you analyze and export the data, and along with the metadata, which is very important, directly to the repository. And ChemConverter then behind the scene works, is an entire code base on its own. And the idea over here is that our services are very much linked to how a chemist thinks, rather than how a software engineer might think about them. This has this benefit that when a chemist wants something or has a problem, they describe it in their terms, and we understand, okay, it is this service that is falling apart, or they have a bug over there. Yeah, great, thanks. So how does our development work? It is mostly in-house. We have a dedicated team, experienced. We have some people who have been there since more or less the start of the entire tech stack, so they understand the entire code base, which is very, very lucky for us, I would say. We try really hard to keep them on board. This also makes long-term decision-making easy because, of course, if you have engineers that are qualified in Ruby, you don't want to move to something else. And sometimes, or more or less all the time, our priorities are decided by who is on the team, who is available. We do go for outsourcing. This has some very, very useful benefits. We cannot do everything in-house, and for very particular things, for example, when we needed to develop a mobile app that could be directly weighing scales in your chemistry lab and put that data, digitize that, and put that into the ELN, we went to an external developing team and got it done. Now, here comes the challenging part in management, because then you have to really define who owns what part of the product, who is responsible for it, and what goes out as an outsourced and what stays in-house. Sometimes this is not very easy, also because people have different kinds of expectations from a code base, and or what are overlaps between two different code bases. But one thing that we have come to realize is that we have to emphasize on stability over speed. So sometimes, yeah, we do not meet our release date, but the end product is really stable, and that our users actually do prefer. Uh, as far as deployment is concerned, this area has seen significant changes in recent years. 10 years ago, there was not so much Docker. There was no standard way of distributing it, and we would tell people, buy a virtual machine, install Ubuntu, and then run this script on it, and it will get all the packages and everything, all the repositories, and you will have a working system. This was complicated, and is still complicated just because of the fact that, yeah, there's Ruby involved. It behaves in certain manners, and to simplify our lives, thankfully, there has been Docker, Podman, and we have moved now entirely, and when I say entirely, at least in terms of support, we have moved to containerized distribution. So we have containerized the entire app. The microservices are also distributed as containers. This entire package is wrapped up as a Docker Compose file for distribution. So people can download the Docker Compose file and run Docker Compose. Now, really, we do Docker Compose because people want to change things. People want to customize how it runs on the computer. But there are people who do not want to run Docker Compose even that. Like, sometimes it's too complicated because you have to pass parameters, or you want certain things or whatnot. So we also have a CLI tool that aids people run Docker Compose behind their backs, do the backups, do upgrades, etc., etc. So yeah, make the life easy for our customer. Uh, when someone gets started with a project, we do really handhold. We have to handhold them because they might have different level of support from their own IT services. They have different level of expertise from IT services, from an IT point of view, and yeah, we want them to get on board as soon as possible, because yeah, it's already too late to enter the digital age. I'll skip a bit in favor of time, but what we want, how do we do this? We have a help desk alongside extensive documentation. So, and the help desk, our goal with the help desk was to provide a one-stop solution that can do everything. Of course, GitHub would be excellent because it provides all these tools that I have listed over here. But our users want to get in touch with us via email. And the reason is that they are sometimes, yeah, not into the coding. They don't want to create a profile on GitHub just because they want to issue a report or something to us. And yeah, they prefer email over everything else, one point of communication. So we use Ahmad, which has an email address, and it gets sent to us as a ticket. And then, yeah, it requires two of us working part-time. We provide bilingual support, which is great. Yeah, and we have had really good feedback about the help desk as well. Now, challenges, I think everyone is aware, hiring is a big, big challenge. We have always, as an RSE community, we have competition from industry. Um, but I'm proud to say we are international, we are diverse. We actually have, I think, our gender ratio is more tilted toward female developers. And one key to that has been that we have been looking for skills. So we don't really go in more when we are hiring people. We don't look for certification for what background you are from in terms of your scientific skills, etc. What matters is what languages you can code in, what level of quality you can code in. And funding has been, as everyone can maybe empathize, it has been a constant struggle. It has been always a constant struggle. Fortunately, yeah, mm, we have been fortunate so far, and the project has worked or expanded as the funding expanded, and we still have a core set of developers in case the funding dries out. So, state of the app, as of now, 2012, we were quite lucky. RDM was getting hot. Resources were available. A web browser that can hold all that amount of information on a single page with a computer to back that, that was becoming easily available. Luckily, we also had a critical mass of users internally. So we had a chemistry lab with 40 users to give us input and tell us what's going wrong. We strive to remain lucky at the moment. So we have these are just the collaboration partners, and we have around 50 confirmed installations. So we do not track our installations, but if someone comes up on the help desk, then we do track that, and we have at least 50 confirmed installations with maybe 50 users on each of them. Uh, we are very, very driven by customer feedback. So that's the key to our success. If a feature is in demand, we try to put that in the ELN. And to end the talk, there is a question to spin off or not to spin off, which is always there in case the funding dries out. We would rather, as a team, no one would like to spin off, because being in the academic ecosystem helps us a lot. We get the feedback. There's a certain amount of trust that we have built with the community. We have worked very hard for it, and they understand that we are doing it for them, and we are not running behind the green paper. So with this, I would like to thank you for deFG for funding us, and for our partners, collaborators, contributors, and users. Questions?